यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, अब हम बात करेंगे आज फ्रिक्शन के बारे में। जैसे हम अभी तक डिस्कस कर रहे थे एनएलएम से रिलेटेड चीजें, जिसमें हमने अलग अलग क्वेश्चंस टाइप करके अलग अलग इक्वेशंस बना के उनके एक्सेलरेशन, टेंशंस, नॉर्मल रिएक्शन, स्प्रिंग के केसेस या कंस्ट्रेंट बहुत कुछ किया है। बट नाउ वी विल डिस्कस अबाउट द फ्रिक्शन व्हेन देयर इज अ फ्रिक्शन इज प्रेजेंट ऑन द सरफेस। तो हम शुरू करेंगे फ्रिक्शन से। देखो, द फर्स्ट क्वेश्चन इज कि फ्रिक्शन होता क्या है। तो इसको समझने के लिए मैं उल्टा चलते हैं। वी विल टेक द एग्जांपल फ्रॉम द स्मूथनेस। मान लो मैं एक सिंपल सा एक एग्जांपल लेता हूं। दिस इज द ब्लॉक विच इज प्लेस्ड ऑन दिस सरफेस। ये इसके सरफेस पे रखा है। मान लो इट्स अ ब्लॉक ऑफ 2 kg एंड अ फोर्स ऑफ समथिंग न्यूटन इज अप्लाइड ऑन इट। लेट्स लो इट इज अ फोर्स ऑफ द 5 न्यूटन। देखो, इफ द सरफेस इज स्मूथ, अगर मेरे पास ये जो सरफेस है, ये सरफेस अगर मेरा स्मूथ हो तो क्या होगा? अगर ये सरफेस स्मूथ हो तो व्हेन द फोर्स इज अप्लाइड द ब्लॉक विल स्टार्ट मूविंग। और ब्लॉक चलना शुरू होगा तो नीचे वाली सरफेस को पता भी नहीं लगेगा। क्यों नहीं लगेगा? बिकॉज इट इज स्मूथ। तुम इसको ऐसे सोच सकते हो जैसे देयर इज अ लेयर ऑफ बिटवीन द टू सरफेसेस। ऊपर वाला चला जाएगा, नीचे वाले को पता भी नहीं लगेगा, नीचे वाला आराम से बैठा रहेगा। तो इन दिस केस अगर नीचे वाले को पता ही नहीं लगेगा तो इट इज नॉट अप्लाइंग एनी फोर्स ऑन द ब्लॉक सरफेस। अब इसको उल्टा सोच के चलो। इफ इट इज रफ, अगर ये रफ हुआ तो ऊपर वाला ब्लॉक कहेगा मैं आगे चलूं, लेकिन सरफेस क्या है? सरफेस का अब की बार उससे कांटेक्ट होगा। इफ इट इज रफ, द सरफेस इज इन कांटेक्ट विद इट, लाइक दिस इज द कांटेक्ट। ये ऐसे कांटेक्ट में है। इफ दिस इज इन कांटेक्ट, आगे वाला ब्लॉक, एक ब्लॉक ऊपर चलना चाहेगा तो नीचे वाला ब्लॉक उसको चलने नहीं देगा, चलने नहीं देगा। तो व्हेन दिस ब्लॉक विल स्टार्ट या फिर इट वांट्स टू मूव इन द फॉरवर्ड डायरेक्शन, द सरफेस बिलो इट विल अपोज इट्स टेंडेंसी टू डू द मोशन या इट्स मोशन। इसकी उसको अपोज करेगा। सरफेस इसके ऊपर की तरफ फोर्स लगाएगा। And this force that is applied by the surface along it to oppose its relative motion of a block, that is called friction. इसमें ऊपर लेगा तो इसमें नीचे। तो what is friction? Friction is a contact force acts along the surface in contact and oppose relative motion between them. So it will oppose the relative motion between them. It will oppose the relative motion between them. तो उनके बीच के रिलेटिव मोशन को क्या करेगा? अपोज करेगा। जैसे मैं आपको एग्जांपल सिखा रहा हूं कि कैसे अपोज करेंगे। मान लो आई एम टेकिंग मोर एग्जांपल्स। लेट्स सपोज आई एम टेकिंग द एग्जांपल कि दीज आर द ब्लॉक्स। This is a block of 5 kg. When a force is applied on the upper block, like this, the force is applied, F. Let's suppose this is rough. If it is rough, the upper block will have tendency to move in forward direction. So it is in forward direction, it has tendency to move. So the friction that will act between them, it will oppose its tendency, it will act in backward direction. Now according to Newton's third law, all the forces act in action-reaction pair. If the friction is acting in backward direction for this, so it is acting in forward direction for this. So it will oppose the relative motion between them. इस सरफेस से अगर मैं पूछ के देखूंगा कि ऊपर वाली सरफेस कहां जा रही है, तो आगे की तरफ जा रही है, तो इट मींस इसको अपोज करेगा। right? You can see more examples also. मान लो ये मेरे पास एक सरफेस है, ये एक ब्लॉक है mkg का, दिस इज रफ. So when it is rough, you have applied some force on it. मान लो तुमने यहां से एक एक्सटर्नल फोर्स भी लगा रखी है ताकि ये रुका रहे. जैसे सिंपली ये चौक है, इस चौक के ऊपर मैंने एक एक्सटर्नल फोर्स लगा रखी है, बट स्टिल इट इज स्लाइडिंग, गिर रहा है. एक एक्सटर्नल फोर्स भी लगा के स्टिल. तो नाउ इट हैज टेंडेंसी टू मूव इन डाउनवर्ड डायरेक्शन. सो फ्रिक्शन विल एक्ट इन अपवर्ड डायरेक्शन. देयर आर लॉट ऑफ एग्जांपल्स फॉर इट. मान लो दिस इज अ कंटेनर, हेमिस्फेरिकल कंटेनर, हेमिस्फेरिकल बाउल. There is a particle is placed on its surface, and let's suppose this is a rough surface. Now you know कि it has a tendency to move in downward direction along this. So the force will act on it in the opposite direction along the tangent. This is the force of friction. So it will act in this direction for this case. Like I am taking one more example for the cycle. From this, I want to clarify the direction of friction first of all for all of you. Let's suppose this is a cycle and you are moving it cycle is moving in forward direction. आगे की तरफ चल रही है. Now which are the direction of friction acting on the tires of cycle? This is the surface. ये surface है. So it is acting in which direction? That is my question. देखो, if you look at this point, when you will pedal it, जैसे साइकिल के पैडल को मारते हो, the back टायर, जो उसका पिछला टायर होता है, वो घूमता है. अगर ये इसका टायर व्हील घूमेगा तो इट हैज अ टेंडेंसी टू मूव इन बैकवर्ड डायरेक्शन. अगर इसकी टेंडेंसी पीछे जाने की है तो फ्रिक्शन ऑन इट विल एक्ट इन फॉरवर्ड डायरेक्शन. दिस इज द डायरेक्शन ऑफ फ्रिक्शन. सिमिलरली, नाउ लुक एट दिस पॉइंट. दिस पॉइंट विल हैव अ टेंडेंसी टू मूव इन फॉरवर्ड डायरेक्शन. इसको धक्का लग रहा है तो फ्रिक्शन ऑन इट विल एक्ट इन बैकवर्ड डायरेक्शन. So these are the direction of friction for the different cases. For the different cases, it can be these possible, right? Next. Next is the cause of friction. Now, what is the cause of friction? This is the question. So the cause of friction is the relative roughness between surfaces in contact. this roughness is due to interaction between molecules of surfaces in contact. मतलब दिस इज द थिंग, जैसे नीचे वाली सरफेस है एंड दिस इज द अबव सरफेस. When there is a relative roughness between these two surfaces, then these are in interaction with each other. So there is a relative roughness between them, and these are in interaction with each other. When there is an interaction between them, so due to the relative sliding, we can say that the friction will act between them. This is the molecular form. If you will want to see it in large form, it is this. कि ये ऐसे जा रहा है. इस टाइप का कोई फ्रिक्शन है, राइट? तो इट इज ड्यू टू द रिलेटिव रफनेस बिटवीन देम. दैट इज हाउ टू डिक्रीज फ्रिक्शन. First is friction is decreased by increasing smoothness between surfaces which are in contact. Smoothness is increased by using lubricants such as oil, grease, etc. Right? Next. Next is types of friction. First is static friction. friction force that acts between surfaces when there is only tendency to move. Like I am taking this second next thing, static friction is a self-adjusting force. सेल्फ एडजस्टिंग फोर्स. देखो इसका मतलब क्या है, मान लो ये सरफेस है, इट इज रफ, we have taken this block of mass m kg. There the force is applied on it. Now when the force is applied on it, so this block will have a tendency to move in forward direction. It will moving, the friction will act in upward backward direction. Now you can observe this thing कि मान लो मैं एक छोटे से आपको पैरामीटर दिखाता हूं कि जैसे मान लो f की अलग अलग वैल्यूज ले रहा हूं. मान लो f पहले मैंने लिया 1 न्यूटन, तो ब्लॉक किस पे है, रेस्ट पे, मतलब वो मूव नहीं करता, ब्लॉक बाय हैवी है. फिर मैंने लिया f 2 न्यूटन, ब्लॉक स्टिल एट रेस्ट. फिर मैंने लिया f 5 न्यूटन, तो ब्लॉक जस्ट इन अ स्टेट ऑफ मूविंग, जस्ट मूव. फिर मैंने लिया 6 न्यूटन या ग्रेटर देन 5 न्यूटन, तो ब्लॉक मूव्स. नाउ टिल नाउ फ्रॉम दिस टू दिस द ब्लॉक इज एट रेस्ट. So if it is at rest, the net force is 0, so its friction is acting. But it is at rest, yet just move, it's also a state of rest. So you can easily see as the external force is increasing, the friction value will also increasing. Till now it is not in the state to just move, right? That means the friction force will also increase. Friction force will also increase. और increase करते करते वो एक maximum value को attain कर लेगी. It means you can say कि the static friction is acting. First of all कैसा friction लग रहा होगा, because it is at, तो static friction is acting. And if the static friction is acting, still it is at rest. And if it is at rest, so you can say directly कि static friction is a self-adjusting force, self, which will depend on the external agent या external force that is applied on it, right? हाँ, अगर ये यहाँ पर move करने लगेगा, now the block is not in a state of rest, now it is moving, so there is some different friction is acting. But still up to this stage, the static friction is acting and it is increasing continuously, right? So we have written static friction is a self-adjusting force. Next, limiting friction. स्टैटिक फ्रिक्शन को आप शो कर सकते हैं एफ एस से, इसको हम एफ एल से भी रिप्रेजेंट कर सकते हैं. इट इज द वैल्यू ऑफ स्टैटिक फ्रिक्शन when block is in a state just to move. When block is in a state just to move, मतलब just चलने की टेंडेंसी में है, it is a maximum static friction. राइट तो वी कैन से डायरेक्टली कि जो अब की बार हमारे पास लिमिटिंग फ्रिक्शन होगा, इट इज अ मैक्सिमम स्टैटिक फ्रिक्शन, तो इट विल बी लेस देन और इक्वल टू, ये जो हमारे पास फ्रिक्शन होगा स्टैटिक, वो लिमिटिंग के या तो इक्वल होगा या लिमिटिंग से छोटा होगा. यू कैन ऑल्सो से according to F जो होगा वो लिमिटिंग से या तो छोटा होगा या इक्वल होगा स्टैटिक फ्रिक्शन. लॉ ऑफ फ्रिक्शन, according to law of friction, friction force is directly proportional to normal reaction. मतलब friction force is directly proportional to Fn. If we will remove the proportionality constant, it will become mu Fn. Where mu is called what? Coefficient of friction. Right? So, Fs is mu s into Fn and Fl is mu L into Fn, limiting friction coefficient, या फिर mu Ss max. From there you can easily say, because Fs is less than or equal to maximum value, that means mu is also less than equal to mu s max. Right? The third type of friction, which is called kinetic friction. Third type is called kinetic friction. FK से दिखा देते हैं इसको. When body starts moving, then friction acting on its surface is kinetic friction. FK. Its value is constant for given surface value is constant for given surface and is less than limiting friction. ये लिमिटिंग फ्रिक्शन से छोटा होता है. मतलब बेसिकली जो FK होता है वो लिमिटिंग फ्रिक्शन से छोटा होता है. मतलब जो इसका म्यूएस होगा, पहले तो FK होगा क्या? FK इज ऑल्सो म्यू के इंटू FN. सो जो FK है it is less than FL. That is mu K into FN is less than mu S max. मतलब mu K is less than mu L, less than limiting friction coefficient. So it is less than limiting friction coefficient, right? Next is the graph between capital F external force and the frictional force. स्मॉल f और कैपिटल F के बीच का ग्राफ है. एक्सटर्नल फोर्स एज वी हैव शोन इन द अबव फिगर. देखो सबसे पहले व्हेन कैपिटल F is 0 there is no friction is acting. Now it will start increasing and it is a self adjusting force, so it will increase continuously linearly up to the value of the FL. Up to the value of FL. Up to the value of FL it will increase continuously. Now then it will become constant, but its magnitude is less than FL. It will become constant and its magnitude is less than FL. So this is the static limiting kinetic friction FK, whose magnitude is less than the value of the limiting friction. Value of the limiting friction. So that is a graph between the capital F and small f, friction and the external force applied. Next is the angle of friction. angle of friction. It is the angle between normal reaction and resultant of normal reaction and friction. Well, let's suppose this is the block. External force is applied, so it has a tendency to move in forward direction, the friction will act in backward direction. And normal action will also acting in this direction. So normal action is also acting like this. If normal action is acting like this, so resultant of this is somewhere this. In between these two, कहीं पे भी हो सकता है. It is in between these two, let's suppose it is there. That is R, resultant. So this angle in between these two, this angle is called angle of friction. Theta is what? Angle of friction. So theta is the angle of friction. So what is the value of tan theta? F upon Fn. This is the value of tan of angle of friction. Tan of angle of friction. This is a clear thing. Is it clear to all of you? Oh, yes. Write down the problem related to it. Questions लिखेंगे. देखो लिस्ट. Write down the question. A block of mass (10 kg) is placed on the surface and two forces of 15 Newton and 20 Newton are applied on block. As shown. if coefficient of static friction coefficient of friction if block remain at rest then calculate direction of friction and its magnitude. Friction and its magnitude. This is the thing. This is the surface on which a block is placed. This type of block is placed. This is the surface. And there are two forces are acting on it. One is in this direction along the surface, another one is in this direction along the surface. And this is of 15 Newton and this is of 20 Newton. I think आपको दिख रहा होगा कि the surface is placed on the table and the two forces are acting perpendicular to it. So the friction, the net force will be acting in this direction. If we observe the side view of it, it is like this. There are two forces are acting on it. Top view अगर मैं देखूं इसका, so it looks like this. There are two forces are acting. So the resultant is in this direction, friction will act in this direction. Right? So this is of how much Newton? 15 Newton. This is how much Newton? 20 Newton. So it is under root of 20 square plus 15 square. 400 plus 225. So this will come out to be 25 Newton. Resultant force. So friction will also act as 25 Newton because it is at rest. If we calculate the direction, so we can calculate the angle. This angle you can calculate theta. So what is the value of sine tan theta? 15 by 20, 3 by 4. So it is how much? 37 degree. Right? So this is the direction for the angle of friction here. Clear? Next, find the least pulling force applied on the block of mass 5 kg in a direction making an angle (45° from horizontal). As shown. So that block is in a state of motion. Here mu s is equal to mu k is equal to 1 by 3. This is the thing. So this is the block of mass 5 kg. There are two forces are acting. 5G is acting downward. And normal action is acting upward. And the force is applying at an angle of 45 degree. At an angle of 45. It has two components. This is F cos 45, F by root 2. This is F sin 45, F by root 2. Now it has a tendency to move in forward direction. If it has a tendency to move in forward direction, the friction will act in backward direction. उसने पूछा find the least pulling force. So it is in a state just to move. For least pulling force, it is in a state just to move. अगर ये जस्ट टू मूव के केस में है तो पहले नॉर्मल एक्शन निकालो. तो Fn is this. Now it is in the state just to move. तो इसका F by root 2 is equal to friction. That is mu into F. That is F by 3 root 2. Add करेंगे इधर तो 3 root 2 will be the LCM. Four F. What is F? Root 2 G by 4. This is the least pulling force required. This is the least pulling force required so that it is in a state just to move. Right? लिखो इसको.